Logarithms. Logarithms are a function that is related to exponents. And a lot of times they're very confusing for a beginning algebra student just because they're kind of strange and there's a lot of different notation that we're not used to. So let's take a look at what I mean by a logarithm. So here's what I mean when I'm talking about a logarithm. Log base b of x equals y. What that means and what a logarithm means is what power do I need to raise b to get x? So a lot of times you'll see this logarithmic equation be put side by side with an exponential equation like this. These two equations are equivalent, which means that they have the same solution set. You'll get the same answer or solution to the equation as you would for either one. So in both cases, it's what power do I raise b to, that power is y, to get x. Once you see an example, this will get demystified quite a bit. So let's take a look at one. Here's an example. Log base 2 of 16 equals what? What this question is asking is, what power do I need to raise 2 to get 16? The answer is 4, because 2 to the 4th equals 16. There we go. Now, if we were to put this in its other form, in the exponential form, we would get 2 to the 4th equals 16. All right, so just to clarify, when we write something with a logarithm, that's called logarithmic form. Its equivalent form using exponents is just called exponential form. Now you know. All right, let's try a few more examples and see if we can make some more sense out of logarithms. Okay, so here's some more logarithms that we're going to compute. Let's start with this first one, and let's say we're having a little bit of trouble remembering what a logarithm is. And we say, well, I'd like to put that in exponential form and see if I can solve that. Okay. So the small number comes up. What it's equal to becomes the exponent. So we've got a little exponent of a question mark here. And then the big number is what it's equal to on the right. So just for a little bit of practice, we'll change each of these. So the little number comes up and has the right-hand side as the exponent. And then this number in the parentheses becomes our new right-hand side. Lastly, for log base 2 of 1/4, the small number comes up and gets the question mark as the exponent, set equal to 1/4. So we can solve either one of these equations and get the same answer. So 3 to the what power equals 9. 2. 5 to the what power equals 125. 3. 5 cubed is 125. All right, there we are. Lastly, 2 to what power equals 1/4. This one's a little bit different. Remember, negative exponents are good too. So we know that 2 squared is 4, so 2 to the negative second is 1/4. So there we go. All right, so these are exponential forms, and these are logarithmic forms. Now, when I first started with logarithms, back when I was learning them a while ago, exponential form helped me quite a bit. So I'm going to explain that a little bit more about how to convert logarithmic form to exponential form. All right? So here's our logarithmic form. Log base green circle of blue square equals triangle. Believe it or not, this is actually how I remembered how to do logarithmic to exponential form conversions. I plugged in shapes, and for whatever reason it stuck. All right, so let's put this in exponential form. And there we are, in exponential form. So this small number, the base, b, goes up. What's on your right-hand side becomes the exponent, and what's right here is what it's equal to. So what power do I need to raise this to? So there's what power do I need to raise this to get that. That's all there is to it. All right, also, you can use the variable form of this. This is just what power do I need to raise b to? So what power do I need to raise b to get x? And its equivalent form right here. All right, so a lot of times you're going to be switching back and forth between exponential and logarithmic form to help you figure out logarithmic expressions. Now let's break down the logarithm a little bit more and explain its separate parts.